All right, with today's stuff now, it's multiplying scientific notation numbers and dividing them. So it's just like regular multiplication. If you took 0.005 times 3 million, that would give you the answer to this. Because 5 times 10 to the negative third is 0.05. 3 times 10 to the sixth is 3 million. I moved the decimal 6 spots. Okay, so you could do that, but the reason why scientific notation is in with exponents is because you got to use the exponent rules. Remember, when you multiply, if you've got 3 times 2 times 8, does it matter what order you multiply in? No. You could go 3 times 8 is 24 and then take that times 2 to get 48. Same thing with these scientific notation numbers. You don't have to take 5 times 10 to the negative third. You can go in any order. So I could take 5 times 3 and get what? 15. And then take that times, so they put the x on these because we're going to leave it scientific. Take 10 to the negative third times 10 to the sixth. Right. There we're using our exponent rules. When it's the same base, what do you do to the exponents? You add them. So that would be 10 to the third. So there we multiplied it. It's not exactly in scientific notation though. Yes. Because the decimal is not after the first number. Mm-hmm. So all we got to do is, instead of putting it here, we got to move it to there. Now, since I moved it, something else has to switch. Aries.
The exponent will go up by 1.
The exponent will go up by 1 because I moved it one more spot. Okay? Because when you're moving this exponent to get it to here, I stopped 1 too early, so I had to move it 1 more. So that's why you add 1 to that. Okay? If it's this one, we just take 9 times 4 is 36. 10 to the negative fourth and a 10 to the negative 1 makes 10 to the negative fifth. Remember, you add the exponents. Negative 4 plus negative 1 is negative fifth. So, now this one, the decimal is here. It's supposed to go there, so you rewrite it. Now this one's a little different. Since it's negative 5, any idea what it would change to? Negative 4?
I'd be negative 6.
Negative 6? It's going to be one or the other. You either got to add 1 or subtract 1. Because the decimal was here, it should have been here.
Oh, you probably subtracted 1.
Now remember, since this was a negative number, that means I'd have to move it over this way 5 spots, right? So it's going to be 0.00036 following this rule. But I didn't want it after the 6, I wanted it there. Which one of these two should it have been?
Negative 4.
The negative 4, right. They moved it 1 spot too many. They moved it 5 over. They should have stopped right there, so this should have just been 4 over. So, these, you kind of got to think about what to do to the exponent. So this one, they didn't write the whole problem out for you. 2.1 times 10 to the third squared. If you square something, that means what? Take it times itself twice, right?
Yes.
So this problem is actually 2.1 times 10 to the third times 2.1 times 10 to the third, right? So 2.1 times 2.1 is 4.2. 10 to the third times 10 to the third is 10 to the sixth. Do you got to do anything? No. It's in scientific notation. The number is after the decimal.
Jesus Christ. You're already my first best friend. What? You're my second. Oh yeah, I'm always second. Almost got you.
Okay. 4.3 times 10 to the negative 7th times 3.1 times 10 to the 4th. You can use a calculator. You just need to multiply those two. So it's going to be 13.33 times 10 to the negative 7 plus 4? Negative 3. So, the only thing wrong with this, the decimal isn't after the first number. Should have been there. So it's 1.333 times 10
To the negative second.
negative second, yep. That, since it's a negative, that means it was a decimal, it was over here. And they just moved it one spot too many. So they should have stopped there at negative 2 instead of going to negative 3. Okay? So, those are the multiplying ones. The dividing is the same thing, you just use your divide rules. I'll just do an easy one right away. Two scientific notation numbers divided. What's 6 divided by 2?
3.
What's 10 to the 5th divided by 10 to the 3rd? 10 to the 2nd. Because remember, you just use the cancel rule here. There's 3 more on the bottom, so take those 3 off and 3 there. So that's it. Now, if you had one like this, I'll just keep these easy for now. This is one a lot of people do in their head and they get it wrong. This is easy. 4. 8 divided by 2. What will this make?
3. Negative 3.
Because remember, what's the rule? What do you do to the exponents when it's divided? Subtract. Negative 7 take away a negative 4 is
Plus 1.
negative 3.
People usually add them.
Yeah, a lot of times people put negative 11, they just add them up.
Oh, I thought
They do that.
They would be there to divide them.
Oh. So sometimes on these also you have to move the decimal. So 5 divided by 8, not easy to do, so just use a calculator. 5 divided by 8 is 0.625. When it's division, you subtract the 2. You take the top one minus the bottom one. If you can't do it in your head, use a calculator.
It will be positive 4.
That would be positive 4. So, the decimal should have been right here. So it's 6.25 times 10 to the
4th.
It is 4th already. So since I moved the decimal, I got to change that 1.
10 to the 3rd.
It's going to be to the 3rd.
Good job, guys.
Because since it's a positive number, that means you were moving it this way. And you just went 1 too far. It shouldn't have went 4. It should have stopped at 3 to be after the number. So for this one, 2.16 divided by 3.6 is 0.6 times 10 to the 3 take away a negative 7 is 10. Change the sign, change the sign. So again, since this is positive, they were moving it this way. They went 1 too far. So it should move back to there. So it'd be 6 times 10 to the 9th.